Lesson 7.5, factoring special products. And we're still dealing with factoring trinomials, and then we're going to be talking about the difference of two squares. The first thing I want to talk about is, what is a perfect square trinomial? Well, to review perfect squares, we know the square root of 49 is 7, the square root of 64 is 8, the square root of 25 is 5. Those are perfect squares. Your perfect squares would be 4, 16, 25, 36, 49, 64, 81, and so on. Okay, in order for it to be a perfect square trinomial, the first and last terms have to be perfect squares, and then the middle term is going to be 2 times 1 factor from the first term and 1 factor from the last term. So, an example of that would be, we have 9x squared. We know 9 can be a perfect square of 3x and 3x. We know 4 is a perfect square of 2 times 2. Well, to check this, we have to take a term from the first term and a term from the second term. So we're going to take 3x times 2, and we have to double that. 3x times 2 gives me 6x, and we double that, we're going to get 12x. So this is a true perfect square trinomial. Okay. So let's go into our first example, example 1. Is this a perfect square trinomial? And if so, factor. Okay, we have to look at your first and last term right off the bat. Are they perfect squares? Well, x squared can break down to be x times x. 36 is going to break down to be 6 times 6. Okay, well, to check it, we have to take a term from the x squared. We have to take a factor from the 36, and we're going to multiply those. We're going to have 6 times x, and then we have to double that. Okay, so I'm going to get 2 times 6x, which gives me 12x. So yes, is a perfect square trinomial. What this is going to factor to be, it's positive, and when we add, it's positive. So we're going to take a factor, x, and then a factor plus 6, and we're just going to square it. We can do it that way, or we can factor the way that we learned at the beginning. Our factors of x squared, we're going to have x times x. And what are our factors of 36? Our factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Added together, they have to be 12x. That would be 6 plus 6. Okay. Another way to write x plus 6 times x plus 6 is x plus 6 squared. So either way we're going to factor and get the same thing. It's just showing you a pattern to see if there's a pattern. Okay, look at B. Do we have a perfect square trinomial? Okay, well, 4x squared is going to be 2x times 2x. 9 is going to be 3 times 3. Right, we need it to be negative, so if I take a factor from the first term and a factor from that last term, I'm going to have 2x times 3, and I'm going to double that. So I'm going to have 2 times 6x, which gives me 12x, but we need this to be negative. Therefore, I have to make my sign in the middle negative. So I'm going to have 2x minus 3 squared. Okay. Alright, let's go on. Let's look at C. Do I have a perfect square trinomial? Well, x squared is x times x. So far, that's a perfect square. 16 we know is 4 times 4, but remember we have to check it because it has to be 9x. So we're going to take a factor from the last term, a factor from the first term, and we're going to multiply those. So I'm going to get 4x. But then I have to double it. Okay, so that's going to give me 8x. It gives me 8x, not 9x. So no, this is not a perfect square trinomial. Okay, example 2, the problem solving application. Follow along on your app as I go over this with you. We're on chapter 7, lesson 5. And we're on example 2. It says there's a park in the center of Paris, France, and it is in the shape of a square. So I have a park that's in the shape of a square. On a square, we know that all sides are the same. The area of the park, the area is 25x squared plus 70x plus 49. The side length of the park is in the form cx plus d, where c and d are whole numbers. Find an expression in terms of x for the perimeter of the park. So we're wanting to find the perimeter of the park. Well, to know the perimeter of the park, I have to know a side. Okay? I know the area. The area is side times side. Or we could say length times width. It doesn't matter. Okay? But let's factor this expression first. I'm going to look to see if I have a pattern. Do I have a perfect square trinomial? Well, I don't know. 25x squared is going to be 5x times 5x. 49 is going to be 7 times 7. If I check that, and I say 5x times 7 and I double that, I get 2 times 35x, which gives me 70x. So yes, it's a perfect square trinomial. So this is going to factor to be 5x plus 7 squared. That's the area. Okay? Right. In other words, this breaks down to be 5x plus 7 times 5x plus 7. That is side times side. So I know one side of this square. Hey, I'm recording my lesson. It's okay.
This is your work on.
Awesome. Thank you. Right, so I know that a side is 5x plus 7, which means all sides of this square is 5x plus 7. Okay, it tells me, it wants me to write an expression for the perimeter. Well, for perimeter, we know that we add all sides together. But if it's a square, all sides are the same, so I'm going to have 4 times 5x plus 7. That's your perimeter. Distribute out, so I'm going to have the perimeter equals 20x plus 28. Okay, find the perimeter of this square when x equals 8. So the perimeter is going to be 20 times 8 plus 28, which gives me, oops, but y'all can't see that, which gives me 160 plus 28. So the perimeter is 188. Continuing on, let's look at the difference of two squares. For it to be a difference of two squares, there have to be two terms, and we're going to use subtraction because difference means subtraction. And both terms have to be perfect squares. Okay? In the example, do I have a difference? Yes, it's subtraction. Is each term a perfect square? Yes, we're going to have 2x times 2x, 3 times 3. Okay, since this is negative, when I multiply, I know I have to have a positive and a negative, so this would factor to be 2x plus 3 times 2x minus 3. Let's check to make sure our factorization is correct. We have to end up with this by the time we're finished. So 2x times 2x is 4x squared. 2x times negative 3 gives me negative 6x. 3 times 2x gives me positive 6x. 3 times negative 3 is negative 9. So I can see that a negative 6x and a positive 6x cancel out. So that leaves me with 4x minus 9, 4x squared minus 9. That's why we have to have a positive and a negative, because when we multiply, we're going to get that negative 9. Okay. Let's look at this example. Determine if we have a difference of two squares. First of all, do we have subtraction? Yes. Do I have a perfect square and a perfect square? Yes, I do. I have x times x, and then I have 9 times 9. So this is going to factor to be x plus 9 times x minus 9. And then look at B. Do I have a difference? Yes. Do I have perfect squares? Yes, I do, because I'm going to have 3p squared times 3p squared. This next one's going to become 4q times 4q. So to factor that, we're going to have 3p squared plus 4q times 3p squared minus 4q. And that pretty much sums up today's lesson. It was pretty short, sweet, and somewhat simple. The assignment, for some reason I didn't write it down when I copied your notes, but the assignment is 14 through 20 evens and number 42. Okay? And that's it for today's lesson.